Okay, this is A2Pure Maths. We are on Unit 7 and we're looking at the Newton-Raphson method, and this is example 1 then within our 7.2. So it says verify that x cubed minus 5x minus 40 has a root in between 3 and 4. So of course we're going to let f of x equal x cubed minus 5x minus 40, and then we're going to work out f of 3. So f of 3 is of course then 3 cubed, which is 27, take away 15, take away 40, gives us minus 28. We're going to work out f of 4, 4 cubed, 64, take away 20, take away 40, and that then is going to give us 4. So how does that help us? Because this is a negative and this is a positive, it means it's changed sign, so let's just take that down as a sentence. So as f of x has changed sign, and will mean obviously between a positive and a negative, or negative and positive, between f of 3 and f of 4, the graph of the function must cross the x-axis in this interval. Therefore, there is a root between 3 and 4. Okay, part 2 then, let's go back up so we can read it. Using Newton-Raphson method, find this root to 3 significant figures. So our formula for Newton-Raphson, just give me a second here, is xr plus 1 equals xr minus f xr f dash xr. So in this particular case, our xr plus 1 equals xr minus our function, which is up here at the top, x cubed minus 5x minus 40. And because we're subbing in there r, sorry, I've made a wee mistake here, obviously that's a takeaway, isn't it, rather than equals. Okay. For the differentiated functions, what do you get then? If you differentiate this, you get 3x squared minus 5, and I should have a wee r here, and a wee r here, and a wee r here. Alright, from our previous thing, we know there's a root in between 3 and 4, so we're going to start with 4. Why am I starting with 4 rather than 3? Because 4 is closer to 0 than minus 28, so I reckon 4 then is going to be a better option than for a root. So from A, start with x1 equals 4. So to get x2, that's what this does. It's going to be 4, take away 4 cubed, 64, take away 20, take away 40, all over 48. Where am I getting that from? The 4 squared, 16 times 3, 48. Take away 5. So that gives me, take my word for it here, you stick this in the calculator, you get there 4 over 43, so it's 4 take away 4 over 43, so it's 3.90698. That then is the 6 significant figures. So what have I just worked out here? I worked out my x2, and I'm now going to go on then and work out my x3. So how to work out my x3? Now your calculators will do this for you. You can just hit a button and then it'll stick the next number into it. But we're effectively subbing in our x2 in here. So now it looks a bit messy, but we'll do it for this one bit. 3.90698. Take away 3.90698 cubed. Take away 5 upon 3.90698. Take away 40 all over 3 upon 3.90698 squared. Take away 5. Again, so there is a way of getting the calculators to work, and I'll maybe do it in one of the other examples, where you just kind of hit go and it works out, then the rest works out the next one for the next value. If you put that into your calculator, you get 3.90445. Again, that's the 6 significant figures, as that should say up there. 6 significant figures. If we then work out x4, I'm running out of space here. So what am I doing now? Instead of subbing in the previous number, I'm subbing out 3.90445 into this here. And you can take my word for it again, you get 3.90441. So we'll go 3.90698, 3.90445, 3.90441. It's looking like it's, you know, changing very little. So let's write that down then. As there is very little change between x3 and x4, root is 3.9023 significant figures.